Hello, friends. It is Ben again. This is a quick video. That's a lie. This is a video for the elementary functions class. I'd like to apologize for how class went today. There were some questions that were unexpected and just difficult for me to quite figure out how to answer. And I didn't do a very good job. So to try to make up for that, I'm producing a video here where I'm going to go over all the stuff that I was trying to go over in class today, and maybe some stuff that I needed to go over that I didn't think I needed to go over. Okay, so let me talk my way through that stuff. And what I would like you to do is to approach things like we usually do in class. That is to say, with the problems, once you see what's going on and we're about to start a new problem, I want you to pause and try it yourself. Okay. Don't do it with a timer like I have to do in class because we have to kind of get on with things. Please just go ahead and try to solve questions and then unpause and see whether you're doing things the way that I'm doing things. Okay. All right. So bearing with me here, I am going to share screen for AirPlay, share, and then I'm going to come over here, tell it to screen mirror to Zoom. Come on, Zoom. Often at this stage, I suddenly find out that I have to update something on my system. And yay, there it went. Okay, cool beans. So the thing that we're looking at here to start with is just a brief review about how to factor quadratics. Okay, so this first example here, I purposely set something up where you have to get the equation to one side. Okay, now if you went ahead and subtracted everything over to the other side on this, you would end up with 0 equals 1 plus 3x minus 2x squared. I don't like having a minus for that sort of thing, so I would tend to put stuff on the other side. Okay. And one way you could do that is to just rewrite it minus 2x squared plus 3x plus 1 equals 0. But the stuff that we have set up is set up with the idea of having the lead coefficient here be positive. So I would multiply everything by -1 and get 2x squared minus 3x minus 1 equals 0. Okay. Now, if you're looking at that and saying, couldn't you have just done that in the first place? Yes, you're right, I could have. But I was trying to illustrate here this notion of when you move from one side to the other side of the equal sign, it doesn't make a difference which side the 0 is on. Okay. But just to fit the format that we're used to, we kind of tend to do this. All right. So, and as I'm looking at this, I am suddenly realizing that I should just stop and start over, but I'm not going to. So the equation that I was wanting to work here, I wanted to have it so that we ended up with a +1 there. And that means that the equation that I was writing, that I needed to put the 5 on this side and the 4 on that side. Sorry about that. Okay. This is how my whole day is gone. So in as a reminder, the thing that we need to do now is to look at multiplying the leading and trailing coefficients. If the leading coefficient is 1, you can skip all this, okay? But if it's something other than 1, you multiply these, we get 2, right? So I need factors of 2, which add up to 3. Clearly, that's 2 and 1, right? So then I'm rewriting this as 2x squared minus 2x and minus 1x plus 1 equals 0. Okay? You can see that on the first one, I can factor out a 2x, and I'm left with an x minus 1. On the second one, I can factor out a minus 1. I'm left with another x minus 1. You will always get the same factor on that, because if you don't, then this was something that couldn't have been factored, okay? And so this will turn into quantity 2x minus 1 times x minus 1 equals 0, okay? I'm going to actually cut this and just put it on a different page. So once you have the two factors are equal to 0, this doesn't work for anything else on the right-hand side other than 0. But if you got the two factors equal to 0, then you can say that 2x minus 1 equals 0, or x minus 1 equals 0. Each of those is a linear equation that you should be able to solve without any further work, okay? So hopefully that's a good quick review there. We're going to do another one, and this one is just that other equation that I had written down there. And this is to just show the different thing that can go on with these. So I'm going to multiply the leading and trailing coefficients, and I'm going to get 6, right? So I have to think about factor pairs of 6, which have a difference of 5, okay? So the only possibility for that is 1 and 6. I want to have a positive 6 because I end up with a positive out of my total here. So this will become 3x squared plus 6x minus 1x minus 2 equals 0. Factor a 3x out of the front, you'll or out of the first pair, and you'll have an x plus 2 here. On the second pair, factor out a minus 1, and you have an x plus 2. So this factors into 3x minus 1 times x plus 2. Have that equal to 0. Each pair is set each factor is set equal to 0. And solving should be pretty straightforward, okay? All right, so that's just reviewing factoring, okay? Then let's go ahead and review getting the solution to a basic trig function that has a special angle on it. So I'm gonna put this one over here. Nope, that was not the thing that I was thinking of. Okay, we're evaluating a trig function of a special angle. Sorry. So when we talk about sine of minus 11 pi over 6, minus 11 6 pi, if you take a calculator and divide, that's negative 1.84 or something. And so that's close to negative 2, okay? So I'm going to think about negative 2 pi, and I'm going to subtract it from this minus 11 6 pi. So I'm subtracting a negative, so it's an addition, and that is getting me 1/6 pi, or pi over 6. That is going to be my reference angle here, okay? The sine of pi over 6 is one you've memorized. I've advised you all to go ahead and get a sticky note and just write down this chart, because there's these special angles we're going to use over and over again. The sine of pi over 6 is 1/2, okay? Next, we have to think about, in order to do the sine of minus 11 pi over 6, what quadrant is minus 11 pi over 6 in, okay? And so think about the fraction part here. Think about the minus 11/6. We're going to have to go around in a clockwise direction because it's a negative number. 11/6 is it's between negative 1.5 and negative 2. So because negative 3 pi over 2 is less than negative 11 pi over 6 is less than negative 2. Except I've written it in the reverse order, right? If they weren't negatives, I would have the right order. But because they are negatives, the negative 2 pi is smaller, okay, is more negative. But we are between those two numbers. I don't really need to know exactly where between those two numbers, but we're somewhere between those two numbers. Our angle is that, negative 11 pi over 6, okay? So when we talk about the sine of negative 11 pi over 6, we just write down the sine of the reference angle, and then we say plus or minus. Well, in the first quadrant, sines are positive. So we put a plus there, okay? So the sine of minus 11 pi over 6 is 1/2. Oh, okay. Hopefully all are good with that. Then if we do cosine of 7 pi over 4, that's a positive angle. So we're rotating around in the counterclockwise direction. 7/4 pi, excuse me, 7/4, get your calculator, you'll find it's 1.75. The closest integer to 1.75 is 2. So what we've got then is 2 pi. That's the closest multiple of pi, okay? And because 7 pi over 4 is smaller, we will subtract it from the 2 pi. And when we do that, we end up with pi over 4. That's our reference angle, okay? So then we ask ourselves, what is the cosine of my reference angle, my pi over 4? That's one that we have memorized. It's square root of 2 over 2. And then we have to figure out where we are on the plane, which quadrant we're in. So because 7 pi over 4 is about 1.75, then it's smaller than 2 pi, but it's larger than 1.5 pi. And so that says that it is, in fact, here in the 4th quadrant. So I'm going to go ahead and just put an angle there real quick. And here is my 7 pi over 4. Okay. And now I say cosine of 7 pi over 4 is equal to, and because we have something that is in the fourth quadrant, cosines are positive there. And that means that we get a positive square root of 2 over 2. Okay. So, right. So that's evaluating for special angles. Right. So our next thing that we're going to have to talk about here is the basic trig equations. So I'm going to split this up into 2 pages and come back over here. All right. So our basic trig equations, we have sine or cosine or tangent. Okay, that's a different case, but or tangent is equal to a number. For sine or cosine, it has to be between -1 and 1, inclusive. And so here, the equation we're trying to solve comes down to sine theta equals -1/2. For sines, draw a horizontal line and think about on the unit circle. Here's -1, here's 0, here's +1. We need this to be equal to -1/2, so it's somewhere down there. Okay, this does not need to be to scale. It's just to get us the idea of where our angles are. Once we know that our angles are here and here, that's going to help us about what quadrant things are in. Okay. So now I'm going to step over here and say sine of my reference angle is +1/2. I dropped the sign, the minus sign. If it was positive, you don't have to change it to negative. You just need a positive number for reference angles. What reference angle has a sine of 1/2? Well, that is pi/6. How do you know that? You have your Post-it note with the little chart on it. You looked it up on there. Okay. So now we know the reference angle. And we need to do 2 values of theta. I will call them θ1 and θ2 in order to distinguish between them. Okay. And the first one I'm going to get is going to be here in the third quadrant, right? Third quadrant, the closest value, the first closest multiple of pi is 1 pi. So this is going to be pi. Because it is farther along, it is counterclockwise from the pi, it is pi plus pi/6. So you get 7 pi/6. Then for the pi/2, that is something that is here in the fourth quadrant. The nearest multiple of pi for that is 2 pi. And because it comes before you get to 2 pi, you subtract pi/6. And so that turns out to be 11 pi/6. Okay. All right. So this is our solving for basic trig equations. You should go ahead and try this one here, but this time it's not a special angle. Okay. So notice I didn't bother with the plus 2k pi stuff. That's not really important to what we're doing. But if you're asking, if you get a question on the online homework that has that, you go ahead and do it. Okay. So you've gone ahead and tried this. For cosines, we draw a vertical line because it is +3/4. It's somewhere over there on that side. We go ahead and connect this up and see that we have our 2 solutions, one of them in the first quadrant and one of them in the fourth quadrant. We will say the cosine of our reference angle needs to be 3/4. It's not a special angle. So the reference angle is the inverse cosine of 3/4. Okay. If you need an approximation, get an approximation at this stage, but you know. Then the next bit is to say our two solutions. The first one is in the first quadrant. In the first quadrant, the closest multiple of pi is 0. So your reference angle is just your solution there. So we'll just say inverse cosine of 3/4. Again, get an approximation if you need an approximation, but this is getting this part done. Okay. Then for the second solution, that is in the fourth quadrant. The closest multiple of pi is 2 pi. And because this is short of it, you'd say 2 pi minus the inverse cosine of 3/4. Okay. And again, if you need approximations, put an approximation on them. Okay. All right. So hopefully that's got us going. And I need you to copy down the double angle identities there. Okay. And as I mentioned in class, the place these come from is actually going to the sine, cosine, and tangent angle addition rules and putting in a plus a. So 2a is just a plus a, and then somebody simplifies them down. The two extra versions of cosine 2a that we got here come from substituting in 1 minus cosine squared for sine squared, or 1 minus sine squared for cosine squared, whichever one that you happen to be wanting to get. As we'll see later on, these end up being convenient to know to solve certain kinds of equations that you can't solve otherwise. Okay. All right. Then if secant theta is -2, I want you all to spot that secant theta is really 1 over cosine theta. And if 1 over cosine theta is -2, then cosine theta has to be -1/2. Okay. Because we're going to have to know both cosine theta and sine theta, we will stop and look at what's happening here about theta being in quadrant 3. That means it's an angle down here somewhere. Wow, that was I missed the spot that I was aiming for. So this being in quadrant 3 means both sine and cosine are negative. So then we know that cosine squared theta plus sine squared theta equals 1. This is referred to as the Pythagorean identity. It's just used over and over again. So if this has not come up before, please commit it to memory, but it is one of the identities that is true because of how we defined the sine and the cosine. If you have something that's if you have a point xy, it is at a distance r from the origin, and you have x squared plus y squared is equal to r squared, and then the sine and the cosine are defined by y over r and x over r respectively. So you would end up being able to solve this down. Okay. So because cosine squared appears there and it is equal to -1/2, then we can say that sine squared theta is equal to 1 minus the square of -1/2 is 1/4. So that's 3/4. Our sine theta is either plus or minus the square root of that. But because we have something that is in the third quadrant, we don't have to say it could be either one. It is definitely negative 3/4. That is negative root 3 divided by 2. Okay. So for the thing we were looking for, we needed to do sine 2 theta, which is 2 sine theta cosine theta. And we have found out that the sine of theta was negative root 3 over 2. And the cosine of theta was negative 1/2. And so we can do a little bit of cancellation there on one of the 2's. And the 2 minuses will cancel out. And we end up with positive 3 or positive root 3 over 2. Okay. All right. So here on this second one here, we're dealing with cosine 2 theta. You can use any of the cosine formulas that you want, but because I'm very lazy, I'm going to use the version that said 2 cosine squared theta minus 1. And because I'm very forgetful, I'm just going to flip back and make sure that I got the right formula. 2 cosine squared theta instead of a, but minus 1. So I will have 2 times negative 2/3 quantity squared minus 1. That's 2 times 4/9 minus 1. And that is negative 1/9. Okay. So hopefully y'all feel right with that. Now we're going to look at these half-angle identities. You want to jot those down. The first 2 came from putting a over 2, where the a was in the previous formulas, and then doing some algebra to get that to come down. Then this formula down here came from just taking sine divided by cosine. And these formulas came from applying the Pythagorean identity and doing some simplification, right? So this first question here, we're going to talk about finding out the sine of pi over 8. And the way you'll think about that is that it is the sine of pi over 4 divided by 2. The way I found pi over 4 was to multiply by 2, because I'm going to divide by 2 to cancel that out. Okay. So our formula that we have is plus or minus the square root of 1 minus the cosine of the angle there, the pi over 4 over 2. Okay. So we're going to say plus or minus the square root of, and that's 1 minus root 2 over 2 divided by 2. I'm going to go ahead and try to simplify that a little bit by multiplying both the top and the bottom by 2. This is the same idea as what you did to get least common denominators way back in grade school, except here it allows us to distribute through and get 2 minus, see how 1 times 2 is 2, and then the 2 times root 2 over 2 will get you a root 2, and then your denominator would be a 4. Because you know the square root of 4, you can write this as plus or minus square root of 2 minus root 2 all over 2. Okay. Now the plus or minus is a little rougher. Okay. So This one is actually going to be fairly easy, but in general, you're going to have to think about things a bit. Okay. Look at what quadrant your angle up on top is in, right? This one we know is going to be between 0 and pi over 2 because it's in the first quadrant. So I'm going to write 0 is less than pi over 4 is less than pi over 2. And now I'm going to divide it by 2 to get my pi over 8. And then I will have to think a bit to see that that is still less than pi over 2. So we have things in the first quadrant. And that tells us that we're going to use the plus because of the fact that signs of things in the first quadrant are positive. Okay. All right. Other versions of this will have something that's a little rougher. But if you think about this process, you are always going to figure out what quadrant that your original angle is in, and then take 1/2 of that and figure out what quadrant that means that's in. And you can think about it with an inequality. Okay. So for this one, we're dealing with negative 11 pi over 12. Okay. So you can tell that that's close to negative 1 pi. Okay. So when we're figuring out our quadrants and stuff, we'll be able to look and see where that is, and we'll know it's close to negative 1. Okay. All right. Anyhow, though, I'm going to write down here that we're doing the cosine of negative 11 pi over 6 divided by 2. Okay. Just multiplied by 2 to get that top. And this is equal to plus or minus the square root of 1 plus the cosine of negative 11 pi over 6. Okay. Over 2. Okay. So that cosine of negative 11 pi over 6, because negative 11 pi over 6, that was a previous example, we found out is in the first quadrant. It's going to be positive, and it has a reference angle of pi over 6. So the cosine will end up being root 3 over 2. So 1 plus root 3 over 2. All over 2. Same trick as before. We're going to multiply the top and the bottom by 2. And so you will end up with plus or minus square root of 2 plus root 3 over 4. And that's, I need to do that. And that's either plus or minus root of 2 plus root 3 all over the root of 4 is 2. Okay. So we still need to figure out the plus or minus part, but we've got everything else done. Okay. I'm going to take and scoot this, try to scoot this over. And of course, I can't scoot it over without running everything. All right. Okay. So I just needed some space here because we're going to have to figure out the negative 11 pi over 12, where that's close to. So negative 1 pi is going to be less than negative 11/12 pi. Okay. And not quite as far out there is going to be, sorry, I needed to be saying negative 11 pi over 6. So let me go ahead and write it as negative 11/6 pi, like that. Okay. So thinking about the integer multiple of pi that'll be nearby, 11/6 is very close to 2. So negative 2 pi will be nearby because 2 is bigger than 11/6. Negative 2 is less than negative 11/6. So the negative 2 pi will be here. And then you have to count the other direction and figure that this will be negative 3 pi over 2. Okay. Now I'm going to divide everything by 2 and have negative pi is less than negative 11 pi over 12 is less than negative 3 pi over 4. So graphically, we know that negative pi is here. And I should have done it this way. So negative pi would be here, and negative pi over 2 would be here. We're going to have something that's somewhere in between. Okay, so this would be negative pi. This would be negative pi over 2. And halfway between there, we would have negative 3 pi over 4. So our angle is going to be here in the third quadrant somewhere. Okay. So in the third quadrant, both sines and cosines are negative. That means, because what we're dealing with is the negative 11 pi over 12, we have negative radical 2 plus root 3 f 3 divided by 2, like that. Okay. So figuring out the minus sign there has to do with figuring out what actual quadrant that we're thinking about things in. Okay. All right. So the next thing here, we're going to try to figure out sine of theta over 2 and tangent of theta over 2. Okay. Now, in doing this, we're told that tangent of theta is negative 2/3. So we're going to figure out the pieces here for something that is in quadrant 4 with, let's see, like maybe that far down. Not that, yeah. So that is what we're thinking about for our angle, either the angle between 0 and 2 pi or the negative angle, either way. So we're thinking about that as our theta, and we'll put a point that's out here, and we need to have tangent theta be negative 2/3. So since tangent is y over x, I'm going to make my y negative 2 and my x positive 3. Notice not drawn to scale. Okay. So on my triangle there, the hypotenuse is going to be, let's see, the square root of 3 squared plus negative 2 squared. Okay. So that is the square root of 13. Right? So now I'm able to say from this tan theta equals negative 2/3 that my cosine theta and my sine theta, they both have the square root of 13 in their denominators. And they're both, sorry, the cosine is going to be positive 3 over that square root of 13, and the sine is going to be negative 2 over that square root of 13. Okay, so if we need to look any of those up for what we're doing, we'll go ahead and do that. So sine theta, as you recall, went like this. Square root of 1 minus, apologies, we were doing sine of theta over 2. Okay. 1 minus cosine theta divided by 2. I forgot my plus or minus as well. Okay. So we're going to come along here and say, do the plus or minus and have a square root of 1 minus 3 over the square root of 13 all over 2. And if you'd like, you can then extend this out a little ways, multiply top and bottom by the square root of 13, and then have that it's plus or minus the square root of radical 13 minus 3 over 2 square roots of 13. Wish we could cancel something, but we can't. Now we need to figure out the plus or minus, right? So remembering that theta is in the 4th quadrant, that means that, I'll write this in red, 3 pi over 2 is less than theta is less than 2 pi. Okay? If you divide that by 2, 3 pi over 4 is less than theta over 2 is less than pi. Okay? So pi, so less than pi, but more than 3 pi over 4. That is actually going to put you somewhere over here in this range. So this is where our theta over 2 is. It's in the 2nd quadrant. In the 2nd quadrant, signs are positive. Okay? And so we have a positive square root of all this stuff. Okay? So that gets us through that. All right, let's go ahead and I'm going to copy these things here. And I'm going to add an additional page because the next part of this says to get the tangent of theta over 2. And I said I was going to paste that. Okay, I'm just going to put those over there. So I don't remember the formula for tangent of theta over 2. So I'm going to jump back to the previous page. And I can see that I have a plus or minus square root thing that I can work with. But if I use either one of those, I don't have to worry about the plus or minus part. So I think that's the easiest thing to work with. I'm going to do the first one. It has sine over 1 plus cosine. Okay. So I'm writing this down as sine theta over 1 plus cosine of theta. So negative 2 over the square root of 13 over 1 plus 3 over the square root of 13. Okay. we need to get rid of the square roots of 13. So I'm going to multiply top and bottom by square root of 13. And on the top, I'll get just a -2. But on the bottom, I'll get a square root of 13 and a +3. Okay, and we just leave it. That's all we have to do there. So the tangents are considerably nicer than either the sines or the cosines. Okay, same sort of thing here. And again, one that would be a good idea for you to try on your own and come back to it. So we're going to need to know what the cosine of theta is equal to in order to use either of our formulas. So one way we can do that is to say cosine squared theta plus sine squared theta equals 1. And I know the value of sine theta. So that means I've got cosine squared theta plus, because when you square a negative, it becomes positive. Oh, what was that? 144 over 169. Okay. So if you use your calculator to do the subtraction there, you'll find out that cosine squared theta is going to turn out to be 25 over 169. And then that means that the cosine of theta is plus or minus the square root, which is plus or minus 5/13. Okay. Theta is in quadrant 3, which, by the way, means that pi is less than theta is less than 3 pi over 2. We'll need that later. Since it's in the third quadrant, both sine and cosine are negative. So we're going to have a negative for this cosine. Okay. And now, when we talk about sine of theta over 2, we're going to have plus or minus the square root of 1 minus, and that cosine was -5/13, and that's all over 2, right? Okay. And that is either plus or minus the root of, okay, 1 plus 1 plus 5/13 is going to be 18/13. And then divide that by 2, you'll have 9/13. So it's either plus or minus. It's either plus or minus. The square root of 9 is 3, and over the square root of 13. Okay. All right. So deciding the plus or minus, we need to think about dividing theta by 2. And we get that pi over 2 is less than theta over 2 is less than 3 pi over 4. So theta over 2 is between 1/2 and 3/4 pi. That means it's in the second quadrant. Okay. In the second quadrant, signs are positive. Sure, circle that with this. Right? So signs are positive in the second quadrant. Right? Then for the cosine of theta over 2, cosine of theta, I can't write, theta over 2 is plus or minus the square root of 1 plus sine theta over 2. That's plus or minus the square root of 1 plus I have to look back at it. Sine theta was negative 12/13. So plus negative 12/13 over 2, which is plus or minus the square root of, let's see, 1 minus 12/13 is going to be 1/13. And then we take half of that, so 1/26. It seems like a very, very weird answer to me. So we have plus or minus 1 over the square root of 26. Okay. Now, as for the plus or minus, we look back and see that we said that theta over 2 is in the second quadrant. In the second quadrant, our cosine will be negative. So we get negative 1 over the square root of 26. Okay. All right. All right. So this is where we first start really trying to use this stuff to solve equations. So we're trying to solve cosine 2t equals sine t. And I know you can just graph everything and get an approximation. And if that's what you're working for, great. But we're trying to here see these techniques of solving these equations. So the trick on this is that I'm going to replace cosine 2t with the identity for cosine 2t. So I've got to look back all the way to the beginning to see what that was. And that is that I want to use this one here, 1 minus 2 sine squared. Okay. So the reason that I want to use that one is that the other part of the equation has a sign in it. So now I'll have 1 minus 2 sine squared t is equal to sine t. I will have only sines, and that will be better. Okay. So I'm going to add 2 sine squared to both sides and have 1 equals 2 sine squared t plus sine t. And now I'm going to subtract 1 from both sides. And I will have 0 equals 2 sine squared t plus sine t minus 1. But I like to have my equals on the other side, so I'm just going to go ahead and move it over. That didn't change the equation, it just changed what order it was written in. Okay. Now I need to factor those. These will factor into 2 sine t, the 1, and a sine t, the 1 equals 0. If you're wondering why I'm not going ahead and doing all the multiply the leading trailing term and so forth, it's because I'm tired and I would like to get finished with this a little more quickly. This is going to factor into something that will have the plus here, the minus here. Okay. And so we're going to have 2 sine t minus 1 equals 0, or sine t plus 1 equals 0. Okay. The first one turns into sine t is equal to 1/2. And the second one turns into sine t equals -1. Okay. We're going to go ahead and solve both of those on the next page. And paste. Yeah, okay. So for the first one here, we're going to say that since we're saying sine t is equal to something, And I'm not going to be very fancy with it. Sines, you draw a horizontal line. Sines are positive. It must be in the upper half. That means the angles that we're looking for are either in the first quadrant or the second quadrant. Okay. I will figure out the sine of my reference angle is positive 1/2. Yes, I know I didn't change that. If you're looking for a reference angle, it needs to be positive. This was already positive. Okay. But I just want the reference angle. And I look on my chart, my sticky note that I've written all these down on, and the reference angle that has a sine being 1/2 is pi/6. So that means that my values for t, the one that's in the first quadrant will just be pi/6. The one that's in the second quadrant will be pi minus pi/6, which is 5 pi/6. Okay. The next one here, actually, can I just copy the same thing, paste it here, and then take that out? All right, so this time we're thinking about that sine t sorry, folks. I'm trying to drag out the angle marks, and I really didn't expect that to work. Okay. So the sine t is equal to -1. Negative ones all the way at the bottom, positive ones all the way at the top. So this is -1. There is only one solution for it. If you get your reference angle, you would say your reference angle is pi/2, but most people will just go ahead and say, all right, this third solution is 3 pi/2. Okay, that's it. Okay, similar problem. So you should try this out on your own, but it's got a little bit different trick. Okay. When you replace sine 2t, you'll get 2 sine t cosine t equals sine t. Please remember, when solving things like this, you want to get a 0 on the right-hand side. So 2 sine t cosine t minus sine t equals 0. We can factor a sine t out of the whole thing and have 2 cosine t minus 1. Let's say this is equal to 0. So your two possibilities are sine t equals 0 or 2 cosine t minus 1 equals 0. And that one there turns into just cosine t equals positive 1/2. Okay. So if I scoot back over here and grab my picture again, I can drop it in here. And we're going to talk about having sine t equal to 0. Negative ones down there, positive ones up here. Sine t equals 0 is right in the middle. Okay. You can go ahead and figure out that your reference angle needs to be 0. But if you see that it's visually got the two answers being 0 and pi, you can skip straight to that. Okay. So I'm going to write down that my T1 equals 0 and my T2 equals pi. Okay. If you think of it in terms of reference angles, go ahead and say that the reference angle has to be 0 And when you place 0 in the first quadrant, it's 0 plus 0. When you place that reference angle into the second quadrant, it's pi minus 0. And then you work from there. Okay. This other one here of cosine t equals 1/2, I'm going to go ahead and put on another page. Actually, I'm going to put all that on the next page. Okay, and I'm going to have to drag all the stuff that's not red off. And put this stuff up here. Okay. And maybe put this there as well. All right, so for cosines, we draw a vertical line rather than a horizontal line. So, and positive 1 is here, negative 1 is here, 0's in the middle. We want 1/2, so it's somewhere there. Okay, positive 1/2. So the two angles that we're thinking about, one of them is in the first quadrant, one of them is in the fourth quadrant. Okay. And then we're going to think about cosine of the reference angle is 1/2. That's a special angle. The reference angle then is going to be pi over 3. Okay. So we had a T1 already. So here's a T2 and a T3. I'm sorry. Those are, in fact, T3 and T4. We already had 2 solutions. So in the first quadrant, it's 0 plus your reference angle. So you just get pi over 3. In the fourth quadrant, it's 2 pi minus pi over 3 because the closest multiple of pi is 2 pi. And we end up with 5 pi over 3. Okay. All right. So, and that was 4 solutions. All right. So verify the identity problems. If you want to fast forward over this, go ahead. I'm sensing that I probably shouldn't try to verify the identity questions on the exam. But the notion with these is you start with one side and try to turn it into the other side. The rule of thumb is you start with the side that looks the most complicated. To me, that's the right-hand side here. So I write down 1 minus tan squared theta divided by 1 plus tan squared theta. And then I'm immediately kind of lost because neither one of those really looks like it's going to get me anywhere. But since I want to get a 2 theta out of it, maybe now I see a way to do it, but it's just very convoluted. I don't see a way to make progress here. Let's try the cosine 2 theta. Okay. So I have the choice of 3 things that I can write down for that. I think that I want to write down the one that has cosine squared minus sine squared. Okay. The reason that I'm thinking this is that I'm thinking a couple of steps ahead. And if I have a cosine, let's see, if I have a cosine sitting here, then later I can try to divide things and have a cosine squared divided by cosine squared, whereas I'll have a sine squared divided by cosine squared. So My motivation is really that I think I can make this other thing out of it. Okay. So with that in mind, I'm going to try to get something that looks similar on the top and bottom. And the thing I'm going to put here on the bottom is that I'm going to divide by the cosine squared plus sine squared. The reason I can do that is that cosine squared plus sine squared is 1, and dividing by 1 doesn't change things. The reason I want to do that is that I think now I can multiply top and bottom by 1 over cosine squared. And when I distribute through, that will become cosine squared theta over cosine squared theta minus sine squared theta over cosine squared theta. And on the bottom, cosine squared over cosine squared or plus sine squared over cosine squared. Okay. So the top becomes 1 minus tan squared theta, and the bottom becomes 1 plus tan squared theta. And that is the right-hand side. Once again, I did not start by writing down both the left-hand side and the right-hand side. I started with just one side and tried to turn it into the other. That's the whole challenge of verify problems. Okay. Okay, another verify. And the trick is going to be figuring out which side to start with. I'm going to start with this side because I know something I can do to these, and I don't know anything I can do to those. So I'll write 1 plus cosine 2t over sine 2t minus cosine t. Okay. Now, I don't really know what to do with the top. I'm going to put one of the cosine 2 theta formulas in, but I don't know which one. So let's see what we can do at the bottom. Sine 2t is 2 sine t cosine t. We're saying minus cosine t. And on the top, 1 plus cosine 2t. I can see that the bottom has a factor of cosine t that I can make come out there, and a factor of 2 sine t minus 1. Oh, well, the bottom looks pretty promising, right? I've gotten a factor that I wanted. I just need to figure out a way to get rid of the factor I don't want. So that says I probably want a factor. I want to get cosines in the numerator. So I'm going to take the cosine 2t and replace it with 2 cosine squared t minus 1. Okay. That was one of my formulas, right? And now I can see that I can get cancellation from the addition on top. And I have 2 cosine squared t divided by cosine t times 2 sine t minus 1. And now I can see that I can cancel one of those cosines and have 2 cosine t over 2 sine t minus 1, which was where I wanted to get. So, yay. Right. And then, okay. So 11 and 12 are both problems that we might need to do something with at some point. Okay. So this one here says simplifying simplify by reducing to terms of 1 theta. Okay, so my cosine 4 theta, the thing I'm going to think about that is I've got the cosine of 2 times 2 theta. Okay, so I have multiple different formulas that I could work with on this. I think I want to go ahead and work with the one that has signs in it. So I'll write 1 minus 2 sine squared. Because we have 2 times 2 theta, we're just replacing symbols here. We're just putting 2 theta where the 2 theta go. Yeah. And now I have 1 minus 2 times quantity. And I know that sine 2 theta has a formula for it. And that is 2 sine theta cosine theta. And so now I'll square those. And I have 1 minus 2 times 2 squared is 4, sine squared theta, cosine squared theta. So 1 minus 8 sine squared theta, cosine squared theta. Okay. If you go a different route, if you use one of the other 3 identities for that, you'll have an answer that looks different, but is actually the same. All right, this one here, simplify to eliminate the power of the trig function. Now, this is actually going to take advantage of something that you may not have spotted from the half-angle identities. If you remember the half-angle identities, oh, no, that's not what I want to say. Sorry, let me back up. Notice here that we had cosine 2 theta equals 2 cosine squared theta minus 1. Okay. If you add 1 to both sides, you have 1 plus cosine 2 theta equals 2 cosine squared theta. I hope it's clear that I can get cosine squared theta is equal to 1 plus cosine 2 over 1 plus cosine 2 theta divided by 2. So my 2 doesn't look very, oh, great. My 2 doesn't look very good, so we'll patch it up. Okay. So you can likewise do the same thing and find out that sine squared theta is 1 minus cosine 2 theta. These are actually how you figure out the half-angle identities, all right? But if you know that cosine squared, cosine squared theta is equal to that, then cosine to the 4th theta, which is cosine squared theta squared, is really 1 plus cosine 2 theta over 2, the quantity squared. And if you go ahead and FOIL that out, you'll have 1/4 of 1 plus 2 cosine 2 theta plus cosine, it's 2 falling over, plus cosine squared of 2 theta. Okay. So sometimes you might not like that cosine squared 2 theta. So you can go ahead and take that a step farther and have things in terms of 4 theta. Because if cosine squared of 2 theta, if cosine squared of 1 theta gets a 2 theta in it, then cosine squared of 2 theta gets a 2 times 2, or 4 theta in it. And you have 1 plus cosine 4 theta over 2. If you go ahead and distribute it out there, this gets a little bit messy, but it is 1/4 plus 1/2 cosine 2 theta plus 1/4 times, I'm going to distribute the other 1/2, 1/2 plus 1/4 times 1/2 cosine 4 theta. So if you put all the constants together, that is to say the 1/4, the 1/8, you'll have 3/8 plus 1/2 cosine 2 theta plus 1/8 cosine 4 theta. Okay. So I happen to know that there is a certain section in Calc 1 or Calc 2 probably, where knowing how to do that makes a lot of the things that you're working on a lot easier. Okay. All right. This was a very long video. I'm sorry about that. I'm also sorry that I got snippy in class today, but again, it was difficult because I was surprised by some of the questions being asked. Okay. Thank you for your time, and I'll see you in class on Friday.